Hello, everybody. This is Chris McAdoo with the Knoxville Entrepreneur Center, and I am absolutely honored, as always, to be in your ears and in your eyeballs with the Big Ideas Welcome podcast. The KEC, as it's better known, is dedicated to changing lives through entrepreneurship, meeting entrepreneurs where they're at. Entrepreneurs like Jonathan Huffman and his company, Orbital Arc. Jonathan, very happy to have you on the show. Tell us a little bit about Orbital Arc, and a
Yeah.
little precursor here, guys. I always like to remind folks that one of the core enjoyments I get out of this gig is to talk to people and learn about things that I would have never otherwise had the opportunity to learn. So Orbital Arc, it sounds exactly like what you're going to say. Jonathan, take it away.
Yeah, Chris, thanks for having me on. So Orbital Arc, my company, what we believe is that with SpaceX and others doing launch, we now have the engines to get into space. We have the technology to enter low Earth orbit. What we need now are the engines to move through space. So if you're trying to design a satellite mission, you typically will build with basically no margin. You build just enough fuel and just enough power into your system to do the mission, get to the right spot, stay there for, the right amount of time, and no extra. Which means if you have to do anything unexpected, you're going to end up, spending fuel that you can't afford to lose. If you have to dodge a piece of orbital debris, or you want to tweak your orbit just slightly, move up and down, that shaves years off the end of the life of the space asset, and those assets are super expensive. So for companies that are building these satellites, we think we can give them a thruster that performs better than the current state of the art. And specifically, it's very early stage, but it looks from the math like we can achieve a 75% reduction in the mass of the thruster, about a 35% improvement in power efficiency, and reduce the fuel cost from about $3,000 a kilo to about eight, which is managed by switching from xenon, which is super expensive, to a much cheaper gas that ought to actually work a little bit better.
And give a lot of the folks that listen to this, or maybe they might not be familiar with a lot of these terms. So when you say,
Yeah.
reducing fuel cost from 3,000 to 8 cents per kilo, how many kilos do we burn through getting something up in the air? How,
Yeah.
give us a sense of the scale of how much fuel
Yeah.
can be spent.
So, oh man, I gotta memorize the numbers, but like, think of SpaceX. They're building the Starship, right? Like, that ship is the size of a skyscraper. It's like the size of a small skyscraper. So thousands of tons, thousands and thousands of tons. And 96% of it by mass is fuel. So only 4% of that whole spacecraft actually gets into orbit. And then when you're in orbit, that 4% has to do everything you want to do. So it's
Wow.
like, uh, it's extremely high fuel consumption to make it to space. Once you get there, you want to be as efficient as you possibly can, and that's what ion thrusters do. They're different from rocket engines in that they are much more efficient. So like, basics of rocket science, you want to throw stuff out the back of a spaceship as fast as you can. That's the gist of it. And then like, the physics is the equal opposite reaction. You throw something out the back, it pushes you forward. That's all. So when you're launching a rocket, you're using a chemical explosion to do that throwing stuff out the back. With an ion thruster, you're doing the same thing, just with an electric field to throw the ions out the back. So the process is you knock electrons off of your fuel. That gives you a charged particle. That's all an ion is. It's just a charged particle. And then you put that through an electric field. And if it's, positive, you push it away with a positive or pull it forward with a negative, and you shoot it out the back. And it shoots out way faster than rocket fuel does, but it also takes a lot more power. You're putting more energy into those particles as you're shooting them out. So you end up much higher fuel efficiency, but you have to carry a lot of solar panels or a very good power supply. in order to get the energy to do that propulsion, and that limits the throughput. So SpaceX is like burning through 1,000 tons of fuel in like 3 minutes. We will burn through like a milligram per second or less. So it's
Wow.
like so little that like the push of an ion thrust is like if you put a quarter on the back of your hand, like the weight of that quarter pushing on your hand, that's about how much thrust you get from an ion thruster.
Wow.
So
And
it's in space only, and you when you're in space, that tiny amount of thrust can add up over weeks and weeks until you're going really really fast, like many kilometers per second. So,
yeah. And I mean, you're looking, of course, at what's available now,
yep,
but let's think about, the next 2 years, 5 years, 10 years, 100 years, right? Like,
yeah,
where do you
yeah.
see this technology going? What
So
and where does and where do you see technologies like Orbital Arc fitting in
yeah,
terms of like what
yeah,
scale and scope do you see for yourself as well as the
yeah,
industry as a whole?
yeah. So ion thrusters are already very efficient in terms of their fuel, like how they work. Um, the thing that they are bad at is really throughput. It's how many ions can we put through the system at a time, and how little power can we use to do that. And so that's what we're building for is the technology we're using makes ions more efficiently. So we make the ions using a process called field effect ionization. That's been used in like biotech labs since the 80s, but we've figured out how to scale it up so that we can use it in continuous flow. So we're making the ions basically at the point of use, and all of the existing
Hmm.
technologies that are used, they make their ions by making a plasma, and then they have to contain that plasma. And plasma is just like charged cloud of particles. But containing it takes energy. You're spending energy to keep the plasma going. It's like
Hmm.
lighting a fire, and then you have to continually give it fuel. So you're using up power that could be better used to accelerate your fuel, just to get the fuel to be a plasma.
Wow.
So we think we can solve that problem. We can make the ions more efficiently, and that allows much more of the power supply on a spacecraft to go to pushing them out the back. The other thing that we've solved for is how many ions you can make at a time. So if you look at like, I'm going to go deep here. So if you look at plasma physics, there is an equation. It's called the Child-Langmuir equation. And it's a fancy name, but it basically is like how many ions can you send across a gap of a given distance with a given field.
Okay.
And what you find if you look at that equation is that the smaller the gap distance is, the more ions you can put across it. And so what we did was basically just made the gap distance really, really small. Like we scaled it from what NASA uses right now is like a couple millimeters, down to what we are going to use is a couple microns. So really, really small gap. And when you do that, you get like 1,000-fold improvement in the throughput rate for a given emitter size. So other ion thrusters are going to be like that big
Yeah.
to give you, a certain amount of thrust. Ours are going to be like that big, like down
So
to
from the
from
palm
like
of
inches,
from the
from
palm of your
inches to
hand,
millimeters. Yeah,
yeah, down to one of the a wrinkle in the palm. What
basically.
is um so the interesting thing here, John,
Yeah,
is also we are using terms, we are introducing a lot of technology to
yeah.
the folks, that are listening. But you got your MBA
Mhm.
not in propulsion science, right? And so you've
Yeah,
taken an interesting path. Uh,
yeah.
I guess this is not, this is your second startup. Your
Hmm.
first was you were actually doing card and board games,
Yeah,
which is
yeah.
obviously a total straight line to ion propulsion. To anyone listening, like obviously that makes
Yeah,
sense.
Yep.
And one of the coolest things and the most exciting and terrifying things I think about entrepreneurship is the embrace of that change,
Yeah.
like those sort of specific life instances that become change agents. So tell me specifically
Mhm.
about what, sort of after the cardboard games and card and board games, you did some consulting. Tell me about what actually led to the big idea that led to
Mhm.
Orbital Arc.
Yeah. So I did this card game and board game company called Blue Shoe Games back in 2013, and that like we were good at making games. We were pretty bad at selling them. So we didn't know how to market them and eventually just ran out of money and shut the thing down. The games were pretty good though. The that experience, I loved it. I had so much fun like learning how to build the games themselves. And I was like, geez, the thing that failed here was marketing. I should probably learn marketing. So I went and got an MBA in marketing. And also at the same time studied entrepreneurship and management consulting. Came out of that and was a consultant for about 6 years, a company called Creo. I was their seventh employee. So I like helped grow that company and worked mostly with life science and biotech labs. And so like I was in that scientific world already,
Mm-hmm.
but nowhere near space. And what ended up bringing those two things together, like the biotech labs and the space, you know, idea together was writing. I wrote a short story on Quora, of all places, about time travel. Like 120,000 people read it, and one of them was the CEO of a video game company. And he loved it. He reached out and he said, I want you to write for my game. I want you to be our world builder. So, job of a world builder includes figuring out how technology is going to work in the game. And it's a sci-fi game, so I needed to figure out, how do you move the spaceships around? And they were big spaceships, like giant aircraft carrier sized robots. So those are heavy, and so it takes a lot of thrust to move them. Um, and if you did that, the only tech we have today that could do it would be chemical rockets. And if you did that, the spaceship would be 95% fuel. You'd shoot it once, it'd explode, and it would be a pretty bad game. So I was looking into alternatives to that, how you move something that big with very, very high fuel efficiency. And the answer is probably fusion reactors and ion engines. But in order for it to work, you have to increase the throughput of the ion engines. You have to get much more, many, many more ions through those systems than we currently do. So I started looking into how you could do that. I got obsessed with it. I spent like a year and a half reading people's PhD theses. And and at the end of that time, like it really looked like I had an idea where the math checked out. And there have been a couple of slight changes since then, but essentially the math did check out. And the company was born. I asked my wife if I could quit my job, and she said yes, and here we are. So
So it's kind of crazy, to take that like from that science fiction world of world
yeah,
building, but that we live in a world where, like, oh, wait a second. Like that
yeah,
math, like you said, the math checks out. So where
yeah.
are you guys? Where is the company now in development? Are you prototype? Are you still inside?
hmm
What's the timeline look like?
Yeah, so we are working on a proof of concept. It's great to be able to say like I've had physicists look at this math and they think it's right. It's a lot different to be able to say I built the thing, it works, right? So that's our next step is to build the thing and show that it actually does work. In order to do that, because we are like shrinking down the size of these emitters so much, I have to have a nanotech lab to actually build this stuff. And that's how I ended up at in Knoxville, and actually with Techstars Industries of the Future was Oak Ridge National Lab has a nanotech lab, and so I put in a proposal to use it, and they said yes, and I, you know, partnership with Techstars helped with that. So being in Knoxville gives me the opportunity to actually like get a chance to use the tools I need to build this thing for real. So it's a huge deal.
That's awesome. And how has the reception been, from say like the entrepreneur in the science community here?
Yeah. I'd say just super open. Like, I've been chatting with the people at the Center for Nanophase Material Science over at Oak Ridge, and like these are world-class scientists. I send them an email and they answer it like in an hour. It's crazy.
That's
The same has been true of the community in Knoxville, like around the Techstars area. The people that have come in have been just fascinating and super giving of their time, and it's been a delightful experience, like working with them and talking to them and you know being excited about what they're doing and having them be excited about what I'm doing. So.
Man, that is awesome. If somebody wants to learn more about Orbital Arc, where can we send them?
You can send them to our website. That is orbitalarc.com, with HTTPS www dot whatever. The other thing to do would be to reach out directly to me on LinkedIn. Just find Jonathan Huffman. I'm the only one that's got Orbital Arc by his name. So if you find that one, it's the right one. And other than that, man, I gotta up my social media game. I don't do Instagram or Facebook or any of that stuff. So sooner or later, somebody needs to reach out to me and offer to be an intern to run our social media platforms.
So if anybody out there is interested, you know where to find him. Jonathan, Orbital Arc, member of the Techstars Industries of the Future Accelerator here in Knoxville, Tennessee. Man, thank you so much. Excited to see where, literally where this technology takes us. Thanks for being on, man.
Yeah. I mean, we think we can open the door to the solar system. So where we can go, to Neptune and back, baby. Let's do it.
Let's do it.